Hi, my name is Florina Muntenescu. I'm a developer advocate at Google. And today I'm going to tell you about data persistence in Android. Well, to be honest, for a long time in my career, working with databases was actually something that I was trying to avoid. And here's why. There was so much boilerplate that I needed to write. I had to do all of these cursor get string of some column, cursor get int of some other column was just something that was kept on repeating. Then, as the schema was changing, I also had to implement migrations, and usually I ended up in a mess of if, else, switch, while that I don't want to remember. And then, although you can test SQLite API, it's not the easiest and the nicest thing to do. And then the worst thing that I did, please, let's keep this between us. I ended up doing database operations on the main thread. But luckily, earlier this year, we released Room, one of the architecture component libraries, that helps solving all of these problems. So what I want to do today is give you a little bit, or tell you a little bit about the main components of Room. And then I want to go more in depth with two features that I really like. Queries and migrations. I want to tell you a little bit of how to implement them. I want to tell you a bit more how they work under the hood. And most of all, how to test them. So, components. Let's say that I have a dessert class that has an API level and a name. We all know what kind of dessert this is, right? And what I want to do is have a table in my database that's called desserts that has a column that's the API level, and another one that's the name. And I want every row to be actually an instance of that dessert. Well, with Room, this is easily achieved with the help of the @entity annotation. More precisely, the classes that are annotated with @entity can become tables in your database. And Room will make sure that these tables are created at the right time. So we annotate our class with entity. We set the table name if we want. If not, it will just use the class name. We can set the primary keys and the column names. OK, now that we have our tables, I want to be able to work with that, to access that data, to be able to do queries, insert, update, and delete. Well, to do this, we use the DAO annotation. DAO stands for Data Access Objects. So more precisely, we will annotate with DAO interface classes where we will define those queries that we want to use to access our data. Most of my mistakes are actually done due to bad typos or copy-paste, like writing desert instead of dessert and adding some random stuff. Luckily, with Room, I can already see this at compile time, because you'll automatically get an error saying that, hey, that table name doesn't exist. And if you write wrong the column name, you will get a similar message. OK, we define our entity. So we know the tables, but how do we define the database? Well, this is done with the @database annotation. More precisely, we would annotate with database an abstract class that extends the Room database. And here, we would build our database. And also here, we would define the DAOs that work with that specific database. OK, there are 4 types of queries that you can do: insert, update, delete, and query. I'll start by talking about insert, update, and delete because they work pretty much the same under the hood. So I was saying that we're using a DAO interface where we define our methods. So what is Room actually doing? Room is the one that generates the implementation of this class. So it will implement our dessert DAO. And inside, it will use a Room database, which is actually an instance of our database that we previously created. Also, Room will automatically generate the implementation of all of those queries. So it will do begin transaction, do some insert, and set transaction successful, and then end transaction. And what I really want you to note here is that Room is the one that takes care of all of your transaction. So it's the one that starts and ends a transaction. So this means that if you want to insert desserts in a batch, for example, Room will take care of this for you and will make sure that the insert will happen atomically. But what if you have a different case? What if you want to do other operations like adding a dessert and removing a dessert, and you want this to be an atomic operation? Well, with the help of Room, all you need to do is just wrap those DAO calls in your own transactions. So you will use an instance of your database, will do begin transaction, do your DAO calls, set transaction successful, and then end transaction. Okay, what's the threading model for insert, update, and delete? Well, all of these are synchronous. And spoiler alert, query is also synchronous, or can be also synchronous. So what does this mean? It means that those queries will be run from whatever thread you're calling them from. So this means that if you're going to run these from the main thread, you'll end up with your app crashing with illegal state exception. So this means that all you need to do is just use your preferred method of handling threads in your database and make sure that you're executing all of these queries off the main thread. Okay, we talked about these three. Let's go to query. So let's say that what I want is to get a dessert for a specific API level. We can do this in multiple ways in Room. We can do this synchronous, so just get dessert by API level. So this will behave similar, as I said, with the insert, update, and delete. But we can also do this asynchronously via observable queries. So here, Room will return either a live data, which is also an object from the architecture components, or a flowable object, which is part of RxJava, RxJava 2. Okay, what's an observable query? So both live data and flowable, as a concept, work pretty much the same. So let's say that we have this table with this content. So an API level 3 and a cupcake, an API level 4 donut. And what we want to do is get dessert with API level 3. What we will get is initially 3 and cupcake. But then, when we modify our database, so for example, we update the name of the dessert for API level 3 and we say cookie, because it sounds better, then automatically both live data or flowable, wherever you're using, will emit and will have the new data. So you would have 3 and cookie. Things work a little bit differently when you don't have the data in the database. So if you're using a live data, for example, and you want to get the dessert for API level 26, which we don't have it there yet, you will get null. But if you're using a flowable, you won't get anything because flowables do not support null. So this means that neither on next won't be called and on error also won't be called. And because this is an infinite stream, of course, on complete also won't be called. But whenever you get something, so for example, for API level 26, you'll get O, then automatically this will trigger and you'll get your object. But what if you really want to handle that case, the case where the data is missing? Well, one possible solution is just to return a list of dessert in this case. So this list will be just an empty list in case that item doesn't exist, or a list containing one item if that item really exists. Okay, let's see what's going on with the threading. I said that they're asynchronous, but where are things happening? Well, by default, Room guarantees that the query itself happens on the background thread. But if you're using a live data, the result will be returned on the main thread. Whereas if you're using a flowable, the result will be returned on whatever you're observing on, whatever scheduler you're using. So now we've defined our DAOs, but really want to make sure that we did a good job defining them. So let's see how we test them. In order to test the DAO, you need to implement an Android JUnit test. And here, you would have a reference to your database and to your DAO that you're testing. So what you need to do is, well, first, to get a reference to that database. Roam leverages the capabilities of in-memory databases for this. So before every test, you will create a database, and then at the end, after every test, you'll just close the database. So what's going on with the in-memory database? An in-memory database guarantees that the data that you're putting there will not survive process death. So this means that you won't need to just clear the database at the end of every test. Okay, let's see how we really implement a test. So let's say that we want to check that indeed a dessert can be retrieved after it was inserted. First step is to insert a dessert. Second step, if we're using the synchronous method, is to actually get the dessert based on API level, and then check that the dessert is indeed the expected one. Okay, what if we're using live data? Well, I was saying that things are asynchronous, but Room helps us here because we can add the instant task executor test rule to our test. So this will replace the task executor and will make sure that all of your operations will be instant. So then all we need to do, back to our test, is get the data from the light data. And here I'm just using an utility method from our sample code. And then check that indeed that data is the one that we're expecting. If you're using RxJava, things are pretty similar. You need to use the same test rule, the instant task executor rule, and then verify that indeed when you're subscribing, you're getting the value that you inserted before. Chances are that you'll use your DAOs in a sort of a repository. So for example, you might have a dessert repository that does all sorts of operations with dessert. And what you'll want to do is make sure that you're able to unit test this repository. With Room, this is easily possible because you can just mock the DAOs using Mockito, for example, and then you can just control the unit test easily. What if you're using Espresso? Well, in Espresso, you can use the counting task executor rule. So in order to use it, you'll actually need to extend it and then make sure that you're registering the idling resources. And I'm not going to go into details with this because we have the code in our sample code, and it's a bit more extensive, but it's going to be easy to use. Okay, what's going on with migrations? Well, let's see, first of all, what migrations are. So let's say that in the version 1 of our database, we have a dessert with an API level and a name. And what we want to do is to change the schema and also add the release date to our database. Well, whenever we're changing the schema, we also need to update the version number. And then when we are going from one version to another, we need to tell the database how to upgrade it, so how to migrate the database. If you would use the SQLite API, in the on upgrade, you'll need to say what should happen from the old version going to the new version. And if this is okay, if you just have one version, one or two versions, things end up being quite complicated if you need to go from version 1 to 2, from 2 to 3, 3 to 4, 2 to 4, and so on. So Room believes in single responsibility principle. So this means that all you need to do is implement your own migration class. So this will make sure that this will take care of one migration from version X to version Y. And then in the migrate method, you'll need to say what should happen when you're going from version X to version Y. So for example, if we're going from version 1 to version 2, where we just added a column name, all we need to do is execute an SQL that alters all table and adds that column. And then we just need to add that migration to our Room database builder and tell Room to use it when needed. Okay, so what's going on under the hood? Well, Room is using an identity hash for every schema, every version of your application. And this identity hash is stored inside a Room master table. So if you're pulling the database from your app, don't be surprised if you see something else outside the tables that you created. So let's complicate a bit our use case. Let's say that we have a set of migrations. We're going up to version 4. And what we want to do is go from version 1 to version 4. Well, what Room will do, first of all, is use only the migrations that give you the shortest path. So in this case, it will only use the migration from 1 to 2 and 2 to 4 without needing to go from 1 to 2, 2 to 3, 3 to 4, and so on. So what will happen here? Well, first of all, the migrations will be triggered, so your database schema will be changed as needed. And then Room will update that identity hash. And that's it. So what I want to go now is through some cases. Let's say that you're modifying the schema, so you're changing your entity, and you're not updating the version number of your database. What's going on here? Well, what Room will do is we'll see that in the Room master table, you have a specific version. You have the version 1. But then it will also compute the hash for your current schema. And then it will see that the new computed value is different than the one in the Room master table. And the result will be an illegal state exception. And it will tell you that, hey, you need to update the version number. What happens if you're upgrading the version number, but you're not providing any migrations? So, well, what Room will do is create the schemas, but then it won't really know how to handle that data. It won't know whether, okay, what's the default value? How do you get from version 1 to version 4? So the easiest solution for Room will be to just clear the data for your user. So if you're not providing the migrations, don't be surprised if your user loses all its data. How do we test migrations? Well, to test migrations, Room is using a JSON file. And here you will have pretty much the entire SQL magic of the entire schema. And here you will also see the identity hash that I mentioned before. To implement a migration test, what you will need to do is to write an Android JUnit test. And here you would use the migration test helper test rule. So this test rule helps you create databases in specific versions, and it will also help you trigger different migrations. So let's say that we want to go from version 1 to version 2 and check that indeed when we're at version 4 we have the right data. So the first step is, with the help of the test rule, to create a database in that specific version. So here in version 1. And then we're inserting some data. So let's say a dessert. Then with the test helper, we are running the migrations, and then we're validating them. So what Room will do is we'll check that indeed the schema is the expected one. But what Room won't do is check whether the data is still there, if the data is still correct. So this is something that you need to implement. So next step is to just get a reference to your database with the latest version and check indeed that the data that you expect is there. Room was created from the beginning with the help of the community, and it tried to fix all of the problems or most of the problems that we all have, that we all face. And there are some things that are still not supported. So, for example, virtual tables, or non-null columns, or auto value. If you want to find out more about how Room was created and also the other architecture components, I definitely recommend checking out Eat's talk from tomorrow. So, Room. With Room, you get less boilerplate code, you get compile time check queries, it's easier to implement migrations, it's easier to test, and you make sure that you don't do any database operations on the main thread. Okay, so should you switch to Room or not? Well, the first question is, does your current solution provide all of these? If yes, then don't. Then just continue using whatever solution you are already using. But if not, if you're still having problems with your database, or if you're starting a new project, then definitely start with Room. Thank you.